Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 29th April 2023. The problem statement for today is find number. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says, given an integer n, you need to find the nth smallest number which only contains odd digits, that is 1, 3, 5, 7 and 9. Means no even digits are allowed on that number. For example, 12 will not consider. For example, the starting numbers which only contain odd digits are 1, 3, 5 up to 33, 35 and so on. So the problem statement is simply asking us to find nth smallest number. Nth smallest number means if we talk about the first smallest number which contains only odd digits, so that will be 1. If we talk about the fifth smallest number which contains odd digits, that will be 9. If we consider 10th smallest number which contains only odd number, that means odd digits, will be 19. So similarly, we have to find nth smallest number with the series in this sequence. Okay, so it simply says that no even digits are allowed. So let's go through the given examples here. So the first example says n is equal to 3. That means we have to find third smallest number which contains only even digits. So the output is 5 because first three numbers are 1, 3 and 5, and here 5 is the third number, hence it contains only odd digits, where it contains only odd digits. So that's why the output is 5. When we look at the second example, so the second example is saying we need to find 13th smallest number. So here the output is 35. In explanation it is given that first 13 numbers are 1, 3, 5, 7, 9, then 11, 13, all these things, and see after 19 it is directly going to 31. It is not including anything of 20 series because 2 will be included in that, and 2 is a even number. So it is from 19 directly going to 31 and so on. So when we count 13 from the starting of the sequence, we will get the value as 35 as the output. So that is the answer here. Okay, so I hope the problem statement and given examples are clear. So the idea behind solving this problem is to use the approach of to use the Base-5 numbering system to represent the sequence of number with odd digits. In Base-5 numbering system, we have only 5 digits, that is 0, 1, 2, 3 and 4. We can map these digits to the set of odd digits by multiplying them by 2 and adding 1. So when we are following that that is Base-5 numbering system, so we get the number from 0 to 4. So to each digit, if you multiply the digit by 2 and add 1, so we'll get the numbers as 1, 3, 5, 7 and 9. For example, suppose we have taken 3 here. So 3 from the Base-5 number system. So if you multiply 3 with 2, it will become 6, 6 plus 1, 7. So we will get, when we follow this approach, that means multiply each digit with 2 and add 1, then we can get the digits in this set, that is 1, 3, 5 and 5, 7 and 9. Okay. So for example, again, if you are checking, if you are looking at the first one, so digit 0 corresponds to digit 1, digit 1 corresponds to odd digit 3 and so on. So using this mapping, we can represent any sequence of numbers with odd digits using a sequence of digits in Base-5. We can then convert these sequence to Base-10 by multiplying each digit by the appropriate power of 10 and summing the results. Okay, so we will be following this approach. So with this approach, how exactly we will solve the problem? So let me explain this one. I'll take the example, the second example here. So let me move to this notepad here. So here in the second example, it is saying that n is equal to 13. So we need to find the 13th smallest number, number that contains only odd digits. So we have two variables here. like digit place 1, digit place is equal to 1 and result is equal to 0. So we will be initializing these two variables. After that, what we will do, we'll check. We will do certain number of operations till the value of n is greater than 0. So we will be running a while loop for this. So initially n will be 13. So after that, n will be decremented by 1. So that will be the first step. So when we will decrement the n by 1, we will decrement n by 1. So n will be here. If we decrement n by 1, so n will be 12. Okay. So now what we do, we find this one, the remainder of n divided by 5. So if we find this 12 modulus 5, so it will give remainder as 2. So when we apply 2 in this one, that means 2 into n modulus 5 plus 1. So it will give 2 into 2 plus 1. So it will become 5. Okay. So this is the same same formula which I have just explained in the approach. That means we will for each number in the base 5 numbering system, we will multiply with 2 and we add 1 to get the resultant sequence of odd digits. So whatever the remainder we got, we multiplied it with 2 and added 1, so we get 5 here. So 5 is added to the result. Okay, so whatever the value we'll get, we will add it to result. So result will be 5. Okay, and this will be multiplied by digits place. So which is anyway 1 in the first sequence. So so it will be like actually the calculation will be like something like result plus equal to 5, whatever the value we have got, into 1. Okay, so now the result is 5 because initially result was equal to 0. So now what we are doing, that n is updated by dividing it by 5. So whatever is that value here, whatever the value of n we have got, we'll divide it by 5. So we'll get the value as 2 again. So after dividing it by 5, we get new n is equal to 2. Okay. Now after this, the digit place which was indicating which value was initially 1, we multiply it by 10. So that the digit place will become 10. Actually we are using this digit place to calculate to shift the digit to form a number. That means if you are getting 3 and 5, so the output will be 35. So it will be like 3 into 10 plus 5. So for that purpose we are using this 10 in this digit place here. So that we are multiplying it by 10, so that when we add it to a number and we add when we multiply this 10 with a number and when we add another number, so it will become a 2-digit number or 3-digit number, as many digits are involved in the given input. Okay, so once this is done, so again we check. Now value of n is equal to 2. So what was the initial condition initially? In the while loop, the condition was n should be greater than or equal to 0. So that condition still holds true, that yes, n is still greater than 2. So now we will repeat the same step. We will decrement n by 1. We will decrement by n by 1, so it will become 1. Again we apply the same formula here. So we will get this resultant as this formula as 2 into 1, because the n is equal to 1, so n modulus 5 will give 1, so 2 into 1 plus 1, so it will give 3. It will give 3. So now whatever the value we have got, now if you try it adding to the result variable, so it will be like 3 into 10 plus the previous value of the result. Okay, so it will be like this one. We will be doing the same operation here. So last time value was 5 here, so now it will be like result is it will be like result is equal to result plus whatever the value of this operation we have got, that was 3 into digit place was 10. So it will be like 3 into 10, 30. 30 plus 5, it will give 35. So it will be 35. Okay. After that, again we multiply digits place by 10. So now the digits place will become 100. Initially it was 1. In the first iteration we multiplied by 10, it became 10. Now again we multiplying it by 10, so it will become 100. But now after that we try to update n again by dividing it by 5. So this time we get the value of n is equal to 0 now. So where the condition, so after that when it goes again to check in the while loop, so the condition n is equal to greater than 0, that is false, and it comes out of the loop, and whatever the value contained in the result, that will be printed as the output. Okay, so I hope the this approach is clear, this example is clear, whatever I have explained. So with this approach only, let's try the coding of it. I have just prepared a solution just to save time in typing. Let me just copy it here. Here against each line I have given the comments so that it becomes easy in understanding. So I have done the same thing whatever I have explained in the example. Digit place I have initialized it with 1, result was initially 0. So while n is greater than 0, n is equal to greater than 0, then n minus minus, that is we are decrementing the value of n by 1. So this n minus minus operation is performed to adjust the mapping offset between the range of the numbers that contains only odd digits and the range of the natural numbers. In the range of numbers containing only digits, the first number is 1, the second number is 3, third number is 5, and so on. However, the range of natural number, the first number is 1, second number is 2, and third number is 3, and so on. Therefore, to map nth number that contains only odd digits, the correct position in the range of natural numbers, we need to decrement n by 1 to count this offset. Okay, I hope this the reason is clear that why n hyphen is done. Because suppose if we have just only the value of n is equal to 1, so we need to find the first smallest number. So if we apply that in this formula, resultant it will be, so if we are not doing this operation, so it will be like n minus, that means 2 into 1 plus 1, it will be 3, but actually the first number that contains only the odd digits will be 1 only. So that's why if we do it minus minus, so it becomes 0. So when we apply it to this one, it will be 2 into 0 plus 1, so the output will be 1. So the first number that contains only odd digits will be 1. Similarly, if we go for 5, so if we do not do this one, if we do not do this, then n modulus 5, it will be again 0 only. So the output it will be 1. But for the fifth number that contains only odd digits is 9. If you look at this sequence, 1, 2, 3, 4, 5. So fifth is 9. So what we are doing n minus minus. So it will become 4. Okay. So now when we do n modulus 5, that means 4 modulus 5, it will give 4. The 4 into 2, it will become 8. 8 plus 1, it will become 9. So 9 is the output. I hope this reason is clear that why n minus minus is done. So after that, we are applying whatever is the value of n modulus 5 in this formula, and we are getting the results place. And whatever we are getting in this one, we are multiplying it with digits place. So initially it was 1. For first iteration it will be 10. Next iteration it will be 100. Next iteration it will be 1000. So that so the number of digits contained in the n, depending on that only the value of digit place will be increased in the following iterations. Once this resultant we have calculated, then we are updating the value of n so that the new updated value can be used for the further iteration. And similarly, for the further iteration, we update the digits place value by multiplying it by 10. And whenever this condition becomes false, that means n greater than equal to greater than 0, this condition is not true, then this loop gets terminated, and whatever the value stored in this result variable, that will be returned as the final output. I hope this explanation is clear to you. So let's try compiling this code. So here we can see we have got correct output for this given input. Let's try submitting this solution. So here we can see it has covered all the test cases. So this problem has been solved successfully in Java language. So talking about the, okay, so this was a Java solution. If we I have even prepared a C++ solution. In fact, the code is exactly the same, because here we do not have anything that is specific to C++ solution right now. So let me just copy this here as well. Let me just try refreshing this, reloading this window. I think something is not correct there. So here we can see we have got correct output for this solution. So let me try submitting this solution. I think something was wrong in the previous window. That's why some network issue might be there. That's why it was loading. Yeah, so here we can see we have got the correct, all the test cases covered even for this. So this problem is even solved in C++. So talking about this time complexity of this solution, it is in the order of big of n, big of log n, where n is the input array. This is because in this solution we are dividing the input number by 5 in each iteration of the while loop, which reduces the value of n by a factor of 5 in each iteration. Therefore, the number of iterations required to reach the base case, that is n equal to 0, is proportional to log n, which results in the time complexity of log n. Okay. In addition to this, all the other operations performed in each iteration, such as computing the remainder, multiplying by a constant factor, all of these operations take constant time, and they do not affect the overall time complexity of the algorithm. So one thing I would like to mention you that before this solution I was trying something else, which I have even copied it here. So earlier I was trying the brute force algorithm. So here it is trying to compute each number, and it is checking whether that number, each digit in that number is the odd number or not. If it is, then it is counting the odd digit count, and we are returning the number whenever it is reaching the required nth number. But since this was a kind of brute force algorithm which includes two loops here, one is that while count less than n, and here again for that for the each digit, that means the length of each number, we are performing this operation of checking each digit is odd or not. That's why it was in the order of big of n or n. So this was failing due to time limit constraint. It was failing due giving error TLE. That's why I didn't show this this solution, because it was not working properly. So after that I moved to this solution and it is working fine. Okay, so I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.